Hello, my name is Anubhav Swami and I'm Technical Marketing Engineer working for a Security Business Group at Cisco Systems. In this video, I will talk about Cisco Next Generation Firewall and ASAv in Amazon Web Services. Let's start off with the agenda. I'll start off this video with Introduction to Security in Public Cloud. I will cover Next Generation Firewall or FTDv and ASAv overview. I'll talk about performance numbers, deployment models, licensing, and then I will jump into detailed use cases of Next Generation Firewall and ASAv in Amazon. I also have a demo where I'll showcase how to put multiple ASAs behind elastic load balancer to scale out your network, and it is a stateless scale out solution in public cloud. I also have few reference links which I would be sharing in the presentation as well as in description of this video. Let's begin with challenges for IT. In data center, we are surrounded by a lot of applications, and these applications are accessed from your laptop, your desktop, your phones. You might run into a situation where you have limited resources in your data center. The other option is to have workloads in public cloud and create a connection between public cloud and your data center, kind of a hybrid solution. With hybrid cloud solution or dedicated public cloud solution, you have responsibility of providing similar kind of security that you have in the on-prem data center. So same kind of security is also available in public cloud. You have Next Generation Firewall and ASAv, which can be managed by same operational resources, same management tools as well, and it will provide you same kind of security compliance in public cloud as well. Before I talk about NGFWv and ASAv in public cloud, let me talk about native security available in Amazon Web Services. You have security groups available there, which is similar to access control list on firewall. You have action of allow and drop. You can create security groups based on layer 3 and layer 4 information to control your inbound and outbound traffic. But if you are interested in getting stateful packet inspection, application visibility and control, threat-centric protection, URL filtering and advanced malware protection, or VPN can be remote access VPN or site-to-site VPN, either IPsec or any Connect VPN for remote access users. You can look for security virtual devices such as ASAv and Next Generation Firewall. This is a pretty good slide which will give you more information about entire Cisco security portfolio on the network security side. But for this presentation, we would be focusing on Next Generation Firewall Virtual, ASAv, and Firepower Management Center Virtual. So let's begin with the features of Next Generation Firewall. In public cloud, we have offering for NGFWv in marketplace of Amazon Web Services. This virtual appliance can be deployed in routed or passive mode, and major use cases would be at the edge or providing inter-subnet filtering. You can use it for site-to-site VPN, remote access VPN, application visibility and control, NATing, security policies, URL filtering. You can integrate it with public and private cloud AMP using threat grid integration. On the management side, this virtual appliance is managed by Firepower Management Center, which will provide you functionality for managing, monitoring, and eventing of FTDv. So we also call Next Generation Firewall as FTDv because it uses FTDv image, which is combination of ASAv image as well as Next Generation IPS. Firepower Management Center is required to manage this device. So now if you look at FMC, it is available in various form factors, such as you can deploy it on ESXi, KVM, or we also have a flavor of Firepower Management Center which is available in Amazon Web Services. Apart from that, you can use physical appliance as well to manage these devices, and this device will give you complete information of what is happening in your network from dashboard. Even if you have threat grid decoration or AMP enabled, you can look at trajectory and see what is happening in the network as well. Now let's talk a little bit about deployment models. If you see virtual appliance running on ESXi and KVM, there are different modes available. Routed mode, which is a transparent, which is a layer 3 deployment. Transparent mode is a layer 2 deployment. Then we have inline IPS, where you have two interfaces. One interface is ingress, the other one is egress, and you apply your IPS policies there, and you allow or drop traffic based on the IPS configuration. Apart from that, we have inline tap model, where it is similar to inline model, but IPS will not block traffic. This is for period when you want to evaluate that product, and once you are satisfied, you can migrate to inline mode. Passive mode is similar to IDS deployment. On public cloud side, when I talk about NGFWv deployment in Amazon, we only support two models today, routed model as well as passive model, and this passive model is not available in Azure because ERSpan is not currently supported in Azure. ASAv deployment is similar kind of deployment. We have ASAv available today, providing NAT, ACL, stateful packet inspection functionality, VPN capabilities, REST API. We have recently introduced route-based VPN functionality as well. Dynamic inspection for dynamic pin holding. Active standby HA is now available in Azure. And on the management side, we have ASDM, CSM, APIs, or Cisco Defense Orchestrator. This is a good slide, and it is for your reference. You can look at these features in the docker box. These features are supported. We have feature parity with our other virtual appliances, and on the other hand, we have certain limitations on public cloud, like we don't have IPv6 availability there. VLAN, VXLAN, serial console is not available. So you can keep this slide as your reference slide whenever you design any network for your customer or for yourself. You can just revisit this slide to see what feature is not supported in public cloud today. So FMC is managed by Firepower Threat Defense is managed by FMC. We have NGFWv in C3 extra large instance type available today, and we are planning to bring C4 instances with version 6.2.3 release. And apart from that, we have two models for Firepower Management Center, C3 large and C3 2XL, which gives you more memory on FMC so that it can get more events and perform better. We also have on the licensing model side, we have bring your own license model. We also have hourly and annual license. I will talk about licensing model when I will jump into licensing slide. Just for your reference, I've added a couple of pointers on licensing on this particular slide, but I'll talk about that in detail in the upcoming slide. NGFWv is available today in marketplace, and it is a 4 NIC appliance where first two interfaces are dedicated for management purposes, and apart from that, we have ETH2 and ETH3, which is our data interface. You can put this device today in routed mode or passive mode. And if you have network security groups, and if you want to manage this device, you need to make sure that your SSH, HTTP, and if you have your FMC outside of Amazon environment, then you need to make sure that TCP 8305 port is also allowed. This device can be managed using elastic IP address, or if you have direct connectivity going towards your data center and you're planning to use planning to use your on-prem firepower management center, in that case you can use private IP address of NGFWv to manage it. ASA is again a similar kind of offering, 4 interfaces, but on ASA we have two flavors, ASAv10 and ASAv30. ASAv10 will give you 3 interfaces, ASAv30 will give you 4 interfaces. We also have C3 instances available as well as C4 instances. Licensing model is similar, BYOL, hourly and annual licenses available. On management side, you can use it using CLI, REST API for orchestration. We have Cisco Security Device Manager, which is ASDM. We have Cisco Security Manager and CDO to manage these devices. Now it is available in marketplace, and based on the model you select, you get number of interfaces. For ASAv10 you get 3 interfaces, for ASAv30 you get 4 interfaces. Management interface can be used as data interface as well. So major use cases for this device is remote access VPN, site-to-site VPN, edge firewall, and VPC peering. So on the licensing side, again, hourly, annually, and BYOL. Apart from that, you can use, if you have direct connectivity or direct connect going towards your data center, you can manage it using private IP address. If direct connect is not there, you can use public IP address or elastic IP address to manage this virtual appliance. These are performance numbers for next generation firewall and ASAv. Based on features that you will enable on NGFWv, this performance number may vary. So there are certain features that you can enable, like threat is required for IPS, you have URL filtering, and you have AMP. Based on feature that you want to use, the performance may vary. This is our NGFWv routed deployment model. Firewall is deployed at the edge in routed mode, and Firepower Management Center is managing it. In this example, we have FMC running in AWS in a separate subnet, which is management subnet. So one interface of FTDv is in the management subnet, and FMC is using that IP address to manage this device. If you have your on-prem appliance, you can use elastic IP address to manage it, or you can also use private IP address if you have direct connect between your data center and your public cloud. This is passive mode deployment, where your NGFW will act as an IDS device. You can create ER span, and an ER span destination should be your next generation firewall, so that it will receive copy of the traffic and it will give you alerts and eventing of what is happening in the network, and it will work like an IDS, not like IPS appliance. This slide is to showcase ASAv in routed mode. You have ASAv with 4 interfaces. Outside is also management. So by default, this interface will get private IP, and that private IP address can be mapped to public IP address for management purposes. You can use same interface for production as well as management traffic. Let's discuss a little bit about licensing. On licensing side, we have smart licensing available for NGFWv as well as Cisco ASAv. On NGFWv or Firepower Threat Defense, licenses are added to Firepower Management Center, and Firepower Management Center will push those licenses down to Firepower Threat Defense or NGFWv. We support BYOL model, where Cisco will provide you license, and you will install that license in your smart account, and then you will push that license to FMC, and FMC will forward that license or allocate that license to your Firepower Threat Defense. The other model is hourly license or annual license model, which is directly by Amazon. You will be billed for instance as well as license cost, and this model is appropriate if you have a smaller project where you want to deploy this firewall for a couple of months and then decommission it. You can go for hourly and annual license. In this model, Amazon will bill you for license as well, but there is no tax support available for hourly and annual usage model. Now on the type of licenses, when you deploy this virtual appliance in public cloud, you get lab license, which is enabled by default, which will give you 100 kbps as well as 100 connections per second. You can use when you want to enable complete throughput like 1 gig, then you need to procure base license, which will give you functionality of networking, firewalling, application visibility and control. We also have term-based licenses available, which is available in term of 1, 3 and 5 years. So these licenses are threat license, URL filtering license and AMP license. We also have same licensing model available. In case of ASA, we have standard license, which will provide you throughput and firewalling functionality. Apart from that, if you are looking for VPN, then you can go for AnyConnect licenses. Again, we support smart licensing, BYOL, as well as hourly and annual. There is no tax support available for hourly and annual license model because it is built directly from Amazon. Use cases, I'll talk about a lot of use cases today: secure transit VPC, multiple IP on interface, VPC peering, edge firewall, and site-to-site VPN, inter-subnet communication, remote access VPN, and most important use case is VTI use case, which is route-based VPN. So in this model, we have multiple VPCs, and all VPCs are connected to central VPC, and this VPC is known as transit VPC. This is kind of a centralized security model where we provide our security at the central location, and we call it secure transit VPC. So in this example, all the sites are spoke site, and the central site or transit VPC is hub site. So let's talk about control plane connectivity. In this example, we have CSR1, which is active CSR, CSR2 is standby CSR, and active is in one availability zone, the other one is in availability zone 2. There is a route table between our firewall and next generation firewall. There are proper routes so that we establish our control plane connectivity so that we can exchange routes, and there is a multi-point eBGP running between CSR1, CSR2 and next generation firewall, so that we can learn proper routes. And apart from that, let's talk about data plane connectivity. So if you look at this particular example here, if traffic is initiated from outside, we have proper route. So traffic will go to FTD will forward it to route table. In that route table, we have route for spoke subnet, and based on this particular route, it will go to active CSR, and active CSR will forward to spoke. Now on the way back, traffic will again come to that same CSR will then again consult this route table, and based on the default route, it will forward that traffic out to next generation firewall. This is how we assign multiple IP addresses for in normal hypervisor environment or physical appliance environment. If you want to add additional IP address, you just create translation for it, and virtual appliance starts proxy RFing for that particular IP. But that's not true in public cloud. So when you define anything in the public cloud, you need to go to that particular interface, right click on that interface, click manage IP addresses, and then you need to assign another IP address. Now once that new IP address is assigned, you can go inside UI of your firewall and add translation for it, add proper access control policy so that traffic will come to that NIC and your firewall appliance can process that traffic. Until and unless we perform this particular step, a native fabric of Amazon will not send that traffic to your virtual appliance. This is a good use case where you have multiple VPCs and each VPC is talking to other VPC using a secured communication site-to-site VPN tunnel. This can be a case where you want to connect with your partner or with your customer. You can deploy multiple virtual instances. It can be a combination of next generation firewall or ASA, or it can be same appliances at both sites as well. This is a similar example where I have ASAs at each location, and I have site-to-site VPN tunnel between the two. This is a good example where I have next generation firewall at the edge, and it is providing functionality of edge firewall where I have NATing, security policies, file policies, intrusion prevention policies applied on this virtual appliance. Apart from that, I also have site-to-site VPN tunnel going back towards the corporate data center. This is a remote access VPN functionality which we recently introduced in version 6.2.2. If you have FMC version 6.2.2 and Firepower Threat Defense or Next Generation Firewall Virtual 6.2.2, you can utilize RAVPN and use AnyConnect VPN functionality on your virtual appliance in Amazon. This is an example where I have ASA at the edge, just providing firewall functionality, but between database subnet and web subnet, I have next generation firewall providing threat-centric protection. So this is a combination, and if you want to configure this kind of setup, you need to have static routes defined on the workload so that traffic will come to virtual instance for virtual next generation firewall for further inspection. This is a model where I have ASA at the edge, NGFWv between web and database, and it is providing IPS functionality. I have IPS policies turned on and providing IPS inspection to any kind of traffic traveling between web and database. We also have same kind of model available for ASA as well. You can use ASA at the edge, use it for remote access VPN, site-to-site VPN tunnel. You can use it for inter-subnet communication. For inter-subnet communication, you need to have static routes assigned on the workloads so that traffic will flow through this virtual appliance. This is ASAv and AWS route-based VPN solution. You can build a VTI solution, run BGP or whatever routes you have in your data center. You can propagate those same routes in your route table as well. So there are certain steps for your reference. I've added all the steps here. Create customer gateway, create virtual VPN gateway, attach virtual VPN gateway to your VPC, create VPN connection, and most important part is enable a route propagation so that whenever your corporate data center will advertise any route, that route is propagated in route table of AWS. So this, instead of creating policy based VPN tunnel, you are just doing route based VPN tunnel. So whatever route your route table will run on, you will just forward traffic or you encrypt traffic based on your routes, not based on the policies. Okay, now let's go with the demo. So in this particular demo, we are trying to showcase stateless scale out design with elastic load balancer. In this example, we have ASA in AZ1, availability zone 1, then we have AZ2 availability zone 2. In each availability zone, I have ASA. Now these ASAs are added in the load balancer in backend pool. So ELB is monitoring these two devices, and the moment any traffic will come from internet, it will go to internet gateway. Internet gateway will forward it to ELB. ELB will now load balance it based on 5-tuple information, and it can send it to either of the ASAs, and we provide configuration. You can add multiple ASAs behind the load balancer as well. And in each availability zone, I have web server providing web services. So I'll just go ahead and show you this demo. So now I'm in my AWS console. I'll straight away take you to EC2 instances and show you all the instances that I have. I have two ASAs, AZ1 and AZ2, and 2 Linux boxes running web services. So AZ1 is my first ASA, AZ2 is my second ASA, Linux AZ1 is my first Linux web server, Linux AZ2 is my second Linux web server, and accordingly these devices are placed in the availability zone. I have 2 availability zones, US West 2A and US West 2B. So let's quickly go and check our load balancer configuration. This is my ELB. If you look at this ELB, it is internet facing ELB, and in this ELB I have added 2 availability zones, 2A and 2B. And if I go to instances, I have 2 ASAs, ASA AZ1, ASA AZ2, and both of these ASAs are available and they are in service. So I have first ASA in 2B availability zones, first ASA is in 2A availability zones, second ASA is in 2B availability zone, and all the devices are showing as healthy because we are able to receive probes back from the device. And for probing I'm using port 22, and I have also allowed port 80 in my load balancer. So any traffic hitting on this DNS name will go to both ASAs and it will be load balanced. So if you look at this particular example, I have tried using that DNS name, and I'm going to my second web server, and now I'm using different browser. I'm in availability zone or 1, and I'm using web server in AZ1. So using this particular mechanism, I can add multiple firewalls and increase throughput as well. So I'll just show you that we receive traffic on both ASAs. So these are 2 ASAs. I'll just show you captures which I've applied on the interface. I'll just show you both ASAs. Now I can go back and I can now go to instances, and I can switch off one of the ASAs, and still we should be able to access our services from AZ2. So I'll just go ahead and switch off ASA1, and now I will take you back in the load balancer. Now you will see that only one instance is up and entire load is on that instance. The faulty instance is out of service. ASA AZ1 is out of service now. Now I can still browse my services and I can reach AZ2. Even from the other browser, I'm just going to that same web server, which means that I still have connectivity even in the situation when one of the ASAs is down. You can add multiple ASAs to provide redundancy, and you can also scale out your solution if there is more throughput requirement. And once this ASA will come back up, it will be added back to ELB. So that way it is easier for you to scale out solution, and in the event of failure the other ASAs will provide services. This is the example of NAT configuration. I've added this slide for your reference so that you can see how we translate our traffic so that traffic will come back to the same ASA. If you have multiple ASAs in same availability set, you need to make sure that you translate your traffic on the egress interface so that same firewall will receive traffic back when web server will reply. On the orchestration side, we have Cisco Defense Orchestrator available, which is licensed on per device basis, and it's a cloud-based solution, easy to integrate. You just need IP connectivity and connectivity on port 443 so that you can manage that device, and you can apply same set of policies to multiple firewalls if you have multiple firewalls in public cloud or Amazon. These are marketplace listings available for next generation firewall, firepower management center, as well as ASAv. So you can refer to these links later and get more information on our offerings. We also have YouTube channel which we have created for providing instant update on any kind of new use case that we test or anything that we want to communicate. We generally create a video and post it on our YouTube channel. So this is our YouTube channel. You can subscribe to this particular channel to get updated information. Here we have playlist for firepower design. We have advanced threat solution, we have ACI security solution, and security in public and private cloud. Example of a few videos that we have added to this playlist. So we mostly cover things which are more specific to public cloud. So whenever you see any new deployment use case, you will just see that we have when we see a new use case, we generally create a video and post it here. These are links to videos on AWS. First three videos will show you how you can provision next generation firewall, firepower management center, and how you will integrate it with AMP, so to provide services of network AMP. Second video is about multiple IPs. We have done videos on ASA as well. Apart from that, these are links related to ASAv licensing, next generation firewall licensing. I have also added Cisco live session. That's it for next generation firewall and ASA in Amazon Web Services. I hope you enjoyed this video and thank you for watching.